Problem 2. A balloon rises at the rate of 8 feet per second from a point on the ground 60 feet from an observer. Find the rate of change of the angle of elevation when the balloon is 25 feet above the ground. So let's start writing down information that they've given us. They did tell us that the balloon rises at a rate of 8 feet per second, so that would be how fast the y value is changing. So we know that dy dt will equal 8, and it is rising, so it will be a positive 8. We next know that it's 60 feet from an observer. That's not going to change, so I don't need to write that down. And then it asked me to find the rate of change of the angle of elevation, so it's asking me for how fast is theta changing. And then they tell me that the balloon is 25 feet above the ground, so they tell me that my y value is 25. Okay, from there, we're ready to set up an equation. I notice since I'm using theta, I'm going to use SOHCAHTOA. And I notice that I'm given the opposite side and the adjacent side, so I know that I'm going to be using tangent. So we will have the tangent of theta is equal to opposite over adjacent, which will be y over 60. Okay, and in a previous problem, I showed you how to write this y over 60 could more appropriately be written as 1/60th y. Now from here, we're ready to take the derivative. The derivative of tangent theta is secant squared theta. And since I'm taking the derivative with respect to time, I do have to include d theta dt. And then equals the derivative of 1/60th y would just be 1/60th, but then I also have to include the dy dt. All right, from here we're ready to plug stuff in. I know that dy dt is equal to 8, and that's pretty much, I know that y equals 25, but that's pretty much all I know. So it is time for a side trip. So we're going to use the formula tangent theta equals y over 60. We know that y is 25. So to get theta, we're going to take the inverse tangent of 25 over 60. So if you type in the inverse tangent of 25 over 60, making sure that your calculator is in radians, you will get a theta, which is equal to 0.394791. And you'll notice I went out excuse me, a lot of places, because if my answer has to be accurate to 3, in between the problem I need to make sure that I don't round too much. So that's what we'll use for our theta. So we'll have secant squared of theta, which is 0.394791 d theta dt equals 1/60th times 8, or I could write 8/60ths. All right, now from here, to evaluate the secant, we know that the secant was 1 over the cosine, so it's actually going to be 1 over cosine of 0.394791, and it was secant squared, so this will be 1 over the cosine squared. D theta dt equals 8 over 60. And then from here, to get rid of this fraction, we could multiply both sides by the reciprocal of that fraction. So I know that d theta dt will equal 8 over 60 times the reciprocal of this fraction, which will just be the cosine of 0.394791, the whole thing squared. And so that's pretty much it. When I type that all in my calculator, I will end up getting a d theta dt equaling 0.113. And since it's an angle measure, I was measuring in radians. And how often is it happening? It's happening every second. So that would be my answer. Whoops, second. So that would be my answer for d theta dt.